Alright, so there is a situation where they may actually give us a root to start off with to factor. Normally we'd have to look at negative 252, and there are a lot of factors that we could use or trial and error to get. But if they give us 3i, then what we can do is we know that one of the factors is x minus 3i. Not only that, but in our last video we also learned that the complex conjugate must be a factor as well. So for example, like 2 plus I, the other root must be 2 minus I. They always come in pairs. And so if I use this, I also have x plus 3i. So suddenly when we knew we had to get 4 roots, we actually have 2 already. And so, ladies and gentlemen, to synthetically factor this is actually quite a pain. So I'll try to explain why. Synthetic division with these individual complex roots will actually work. If I put 3i in, I can do the same process, but it starts to get very complicated because I have to do 3i times that, which is negative 9. And then I'm working it out in my head. That would be negative 9i. I add down, I get negative 28 minus 9i. And now if I keep going, I will get 0 in the end, but it's starting to get really complicated because now I got to do 3 times that to get that right there. And so it's not my favorite method. I'm going to show you my favorite method. So let me get rid of these things here. What we can do is actually multiply these together. So we have x squared minus 3ix and 3ix plus negative 9i squared. What that comes out to be is x squared, and this is a negative 1, so that just turns into a positive 1. Now instead of dividing each linear factor out one by one, what we can do is divide out our quadratic factor all at once, and that would be the same as dividing out both of these separately. Now the issue though is, you may remember, we're not able to divide or synthetically divide with this, so I'm creating a long division here. We're going to do it the old-fashioned way. Alright, and then I put x squared plus 9, and I think, how will I get x squared to be x to the 4th? Well, x squared. That'd be x to the 4th. And x squared times 9 is 9x squared, so you need to make sure to put that under the right column. If I take this away, that is really like a 0x cubed, so that would be minus 3x cubed, because I'm taking 0 away. And that would be negative 28x squared. And I'll drop down the next column. Okay, so the next one would be negative 3x, because negative 3x times x squared is negative 3x cubed. This is 0. There's no x squareds because negative 3x times 9 is this. Subtract again. This cancels and this cancels, so I'm just going to have negative 28x squared, 0 x's, and negative 252. Now it turns out minus 28 when I multiply will be negative 28x squared, and negative 28 times 9 is negative 252. So if I take those away, I have a remainder of 0. So I would write it like this: x minus 3i, x plus 3i, and then I have x squared minus 3x. That's the answer that we got up here. Now I still need 2 factors from here, so lucky us, this actually factors. It's not always going to happen that way. You might have to go to the quadratic too. But this factors to be x minus 7 and then x plus 4. So there we have it. That's actually nicer than the rational root theorem, because when we have the two, we multiply them together, we only have to long divide once. There's no trial and error.